This is the Tatung, an amazingly bulky and huge machine that rivals the footprint. In fact, it's slightly larger than your humble BBC or even your BBC Master. Yeah, it's huge, it's massive, with matching monitor. And just to give you an idea, there's the BBC and its personalised cub, and there's the Tatung. Now, this computer is quite capable with 2 disk drives you can have fitted and a whole host of peripheral outputs on the back, a bit like the BBC, but with one notable difference. What's the difference? Well, there's a big speaker at the front of this one, where the BBC has its speaker sort of located at the top there where that grill is. The speaker on the Tatung is that huge thing which is next to all those function keys. Also, the actual Tatung itself has 2 outputs for your monitor. You can have a green screen and monotone looking monitor, or you can have a colour monitor, which is displayed just there. But that's not what we're going to be working on. We're going to be working on this very poorly and broken Tatung monitor, which is, shall we say, a little bit dirty. I'll show you more. So I've taken the lid off, and you can see there clearly it's had a bit of a smack. And also down here there should be, well, there's a total of 3 of those. We're missing 1 of them. So that could be, shall we say, rattling around somewhere. Taking a look at the Einstein itself, it's a nice and clean comparison. Take a look at this monitor though. I mean, there's some proper crummy crud there, isn't there? Eh? Proper dirty. And I've already wiped this down a little bit. So I've wiped the top across there, so you can actually see it using my little paintbrush. But this monitor is faulty, and I'm going to find out what's wrong with it. Now, there's only 2, I mean, look at that. That'll be a good indication of what's wrong with it. So before I can give it a visual inspection, to see if I can, shall we say, inspect it visually, I'm going to have to give it a really good clean. They're on trays, and it will pull forwards and backwards, as you can see. Yeah. But I'm going to take all of these board apart and discharge the tube. And it's, you know, can have a few nice voltages in there. However, I will show you a safe way of discharging that. Some have a built-in flyback resistor there, or bring the charge back out of it. Bigger tubes can probably end up recharging. They're big, huge capacitors really, so they can actually end up getting, even though you may have discharged them, having a charge build back up in them while they're sitting and still give you a little bit of a bite. Yeah. So the evidence shows, judging by that broken corner, and we've got broken bits all over there and here, that it looks like it's had a bit of a fall. Well, I'm going to try and clean this up now and get it so as I can give it a visual inspection before we can trace what is wrong with it. And in order to do that, I'm going to disconnect the tube and pull the circuit board off the neck. There's 2 pieces that I don't want to be gone because I can't replace them. The tube itself, which I highly doubt that is a problem. If anything else, it'll be a spare. And of course the flyback transformer, which is the thing that builds up plenty of thousands of volts to run into the tube there and cause the beams to deflect as the way they do, without going into too much technical detail. To give you an idea just of how much dirt is on this, I've already started brushing that off, and of course it was as black as that, and with a brush you can see, you know, you will clean them nicely, so there's no real corrosion there. And that blue component there, which was that colour all the way across, so you can see I've swept there. See if I can get into there, show you. There you go. There's no blue again. So a lot of this will just brush off but we got to sort of get in there and give it a good clean, and I don't want to have to do that while it's so close to your tube. So the best way to do it is to take it apart. Take a look at that sticker. Somewhere beyond there should be the rest of the word for Toshiba. Oh, obviously I don't want to knock the sticker off, but if we give it a scrape, there we go, you can see the rest of the word. I wonder what the G means. Grimy, perhaps? So in order to discharge the tube, we need to earth this, and we need to push a, shall we say, a contact there to touch the connections inside and take it down to earth. Now I happen to have an earth which is just over there. I'm going to use the soldering. Now I can test that for you because it's all earthed. If you look at that earth there on my my meter, I don't know if you can see that, whether it's too dark. There you go. And how do I test that? Well, I'll show you how I test that, because I'll use my multimeter to show that I've got good earth there to take any electric away. So if I switch my multimeter on and I put the one end of the probe on that earth there. Now this is already connected to that, and when I touch this onto here, you can hear the beep. And it's because that's going through the plug for the earth there, that's going through the earth. So we know that that is connected to a good earth, and it has to be with my desoldering tool. And hopefully that will be enough to discharge this. So by gently pushing that underneath there, and I'll use a plastic screwdriver as well to, I'll show you how to do that now. I'm going to use a plastic screwdriver to help me lift the rubber seal to discharge it. So okay, now if he has been recently charged up, you might hear like a little spark. You want to keep your hands well away from this sort of thing. I'm hoping I can get that underneath there. Yeah, that's it. And make sure I can now lift it up enough without getting too close to know that I've sort of got to the metal contacts. There's no charge there, because I can see the metal contacts. They're sort of hooked together, so I've got to squeeze the hook out in order to get that off. Yeah. There we go. And we're off. We're fully discharged. And of course there's never any power in the flyback transformer, or there shouldn't be. But you know, I knew that. Even I was a bit apprehensive. Has no power in it. Which means it's not safe yet, because there's still a few huge capacitors on here that may be pretty charged up, or probably not. Now I don't want dirt to go inside that hole, so I will cover that hole up in order to give this tube a good brush down at a later date. And I'm going to do that now. Just a little bit of red insulation tape will be enough. You know, I just don't want nothing to go in there really. And of course you don't want to get any sticky on that either really, because you know, there we go. And that means now that when I bring my brush across this, you know, it can be just like that. With that, we need to start disconnecting things, and most of these things are just in plug and play. So they're all on connector ends, and they're able to unplug them. They're keyed as well, so you can't put them in the wrong way. And this is the mains cable just down here. There we go. I mean, just check. Keep checking around as I pull this off. Pull this out gently. This sometimes has got like a band on it that you might need to click off. Free up the wiring. For instance, I'm going to cut this grip off here, being careful not to cut into the wires, and that should then loosen everything. I mean, that is resting quite tightly on there, to be honest. That was a bit harsh. And as you can see, I've just found that was underneath, which could have caused a short if that had been rattling around in there and touched across any contact. It may have shorted them there. Any contacts, the word is going. And oh my word, just take a look at this. I mean, that's proper grime, isn't it? If that gets wet and gets dirty enough, it can arc. The electrons can arc across that. Some of the bits that have fell out from the inside are just there. Yeah. We're getting close now to being able to separate the board from the tube. And now, because I've already made sure there's no real contacts here, just lift this up a little gently and very easily. Just wiggle that off and that's off. And now, hopefully, with that there, which is the degaussing coil unhooked, this one, which is connected to the four colours on the tube, is unhooked. We can now safely remove this circuit board and just, you don't want to pull too quick in case there's anything at all that we've missed. And I think we have. There's a little earth lead down there connected to the back, and that's just basically pushed on, which is also connected to the degaussing coil. Once I pull that off, which hopefully isn't going to be too hard, it may well be harder than we think. I need to get a good pair of pliers actually, so I don't want to pull against the cable, I just want to pull against the connection, and the coil goes in there and off it comes. Now we should be able to remove the tube away from the circuit board like so, which means I can now concentrate on cleaning that out and then cleaning up the circuit board. So I'll remove that out of the way and we'll change over to the circuit board. Here's a top tip here, because you don't want to be catching that tube in there and end up ruining it, is I've got the back of this in a box. Because it's fairly flat and I'm on a wooden floor, the tube is not going to get scratch lined down like that. So I'm just going to turn this over now, put these wires inside where they're not going to cause, ready for cleaning later on. I'll just drop that over, and that should stop me from, shall we say, catching the tube and putting it somewhere effectively where it's not going to get caught. Back to the cleanup of the main board itself. You can see there's a whole host of capacitors in here, and that one looks in pretty poor condition there. We'll come back to that. It's the big ones, the power supply side, that I want to deal with. So I'm going to turn this over and be careful not to catch any wires. This is old stuff now, and you can see usually where the big traces are. I'm going to go across it with the tester, see if there's any charge at all. I highly doubt it. It's always better to be safe than sorry. So with my multimeter you could probably just about make out. Let's push that there. There we go. Which one should we try first? Should we try the big one? And of course the big one is got to find out which connections we're using. There is a fuse internally, and I can see that, and we'll test that in a moment. It would be lovely if it was just a fuse, wouldn't it? And where it gets hot, which will be around certain areas, I always like to look closely at any connections to see if because heat can cause solder to, shall we say, a dry joint or two, which could cause bad connections. Now, is that separated to that? We got no voltage across them, so that's a good sign. There should be a couple of caps at the back. It's just one big cap. All the real caps are next to the transformers here, so hopefully we're going to have hardly any voltage there, and there. Nah, everything here seems to be safe, but I'm not going to settle for that. I'll make sure with my conducting ruler, I'm going to send the voltage into myself, and I'll prove the ruler is conductive. There we go. I can just literally make sure that everything is discharged. Happy to say that I think this unit is now safe to work on, because everything, as far as I believe, is discharged. But don't, whatever you do, take it for granted that everything's discharged, because that's when you come unstuck. So I'll still keep a healthy distance away from things. The back's always a lot cleaner than the top, and that's just the way it is, because obviously dirt doesn't go upwards, it only falls down. It can be statically, I mean, when I wipe it down, you'll see, I mean, there's nothing going to be brushed off there. Nothing at all, is there? Turn that over now, we can see, oh, just look how grimy that is. Should we go for the fuse test? As the multimeter is already in continuity mode, and I'll show you where the fuse is by getting directly above it. Let me see, right. Can you see it? Can you see the fuse? Have you located the fuse? Just check. Let's just get on there. And that fuse is okay. That fuse is okay. So we know that there's no problems on that side, and that's probably a good sign. That means there's no dead shorts, which is usually what can cause the fuse to blow. Yeah. Better start the clean up process then, haven't we? And we need a decent brush to do that. And there's a brush I'm going to use. Nice soft brush. And hopefully you'll be able to watch this in real time. So we can zoom in. Either not clean up or clean up. Yeah, it's starting to clean up a little bit. I mean, I don't want to go over the top with this. I just want to get it clean enough for me to visually inspect everything. And that means that this part here, this is the interesting bit, because you can see how dirty that is. And I don't want to use a vacuum. And the reason why I don't want to use a vacuum, because if any of these components are broken, there's any parts of them in there, it'll get sucked up and I might miss them. So, you know, but I will. The caps look okay, don't they? Yeah. And that cap that I was a bit worried about seems to be okay as well. And I will use IPA in a bit, just to help grab some of that dirt. Oh wow. So I'm going to have a few hours of doing this until I can see everything clearly. And we'll definitely need to get into the flyback transformer, because that's always filthy. There's some dials on there as well that you want to avoid. They're sticking out the back. Ooh. And for the first time in a long time, this is having a bit of a clean. And it's a little bit dusty, so it's probably advisable to wear a mask. Just going to give a little black, a little bit of a brush. There's plenty of flux on this. Just a trace of IPA, just so as I can see all the traces nice and clearly. And now it's starting to look a lot better, definitely on the back. As you can see, look at the flux that seems to be on there. Yeah. And of course the flux, a remainder of the flux from when it was soldered in the factory or whatever. Certainly. Tend not to get problems with these tracks. They're really large, quite big tracks, and the joints look pretty good. Of course, I want to soak some of the flux up rather than just brush it around the board, so I want to get on with a little bit of tissue there. Some of that is what the brush has picked up. We'll be able to see, and I like to dab it down. Yeah, there's a lot of flux there come off. We'll be able to see. And another technique I use is I soak the top of the toilet roll, and then that softens the toilet roll enough for it to soak through, and you'll be able to dab any flux off the board. Maybe you're going down using the bristles basically as a slight hammer, but not enough to damage anything. The dabbing effect always works, and of course I don't want to leave any tissue behind, so if you keep it wet you can see where it's starting to poke through a little bit. Just gently lift it upwards and you can see, oh wow, look at that. Yeah, the board's already starting to look nice underneath, and now I can examine it. I'm looking at a spot there that looks a bit iffy, but don't think there's anything there to worry about too much. Some people use Q-tips, don't they, but when you've got large areas, a little Q-tip that you use for your ears to clean, it's not going to be big enough. Of course, if you're rubbing it, you're going to shred that, and when shredding that you'll end up with bits of tissue everywhere, which could potentially set on fire, but we don't want that when, you know, should you power it up. We want to just get a good visual inspection, especially where there's lots of connections in play. There we go. Now, don't know if you can see down here, so a lot of flux down this end, and I'm not going to desolder that yet. I don't feel the need to, but if we do need to, that might take a really hot iron, and I won't be able to use my solder station for that. I'll need something a bit more beefy to do that. Now I'm happy that that's all clean underneath, enough for me to examine it using the shall we say microscope, and or whatever, you know, anything basically with a zoom lens on it, including the phone. Yeah, because I've brushed a lot of the dirt onto the surface of where I'm working, I've just decided to give that a clean up, and I'm not using this stuff sparingly, I can promise you that, but I just literally don't want any, and those are the bits that have come out of it. Use absolutely tons. Usually kitchen roll's better, but I've got no kitchen roll, so I'm having to use a little bit of toilet paper because we've got plenty of that. Still got stock from when COVID hit. No, only joking. Yeah, there we go. Let me look at the state there. There we go, nice and clean. I don't know what to do with these bits. They're not worth keeping, are they? So I'm just going to put them in my hand and stick them in the bin. Now, surface clean. There was something that fell off that I'm going to have to keep an eye on, and I've lost it already. So we found that inside, which I put over there, which was the clip that was missing from the three that we saw, but there was something else that fell off, and that was misplaced now. I don't know what I've done with it. I'm sure I'll come across it. That was the thing that I found, so we need to find out where that's come from. And it's out the television, and it's keyed, so that might be a clue. So I want to just, it's a very sunny day outside, it's really hard. See those potentiometers there? I want to hit them with a bit of deoxit. There's usually a bit there where it can soak through. All underneath there. Yeah, that was a good one. I liked that one. I felt it going. I felt it squirting in there. When it's not spraying me in the face, I know I've got it. That one's a bit trickier to get to. Let's see if I can get to this one. And that one got in. There we go. Now I can give these a regular twist and work in the deoxit on each one. Hopefully. Yeah, you can feel it. Here, look. That was actually quite stiff, and now all of a sudden they're getting quite light. That's stiff and now it's getting really light, which is good. And same here, that's stiff and now it's getting really light, which means we got the spot that we needed to get. we're looking at that board. I'm wondering if it can come away, and it looks like it might actually come away. Yes, I can actually take this board away from the main board, because if you look here, right at the bottom, there's a connections there, on connections there. Now that will help me to clean it better. So we need to look around. I can see there's 2 screws holding it, or 1 screw holding it here. And is there any other screws holding it anywhere else? Yeah, 1 screw on that main chassis, and 1 down there somewhere. I don't know where we can get to it or not, but it looks like this board will lift away somehow, and that will be handy. I'm going to work out how to do that. Big reveal time. Now that is clean, and you can still, some of the IPA is still drying off, because I really do give it a good soak, and I'll just let that dry naturally. And you can see on the board which components have been getting hot because of the scorching in and around there. But yeah, compared to what it was when we started this to what it is now, and it's the same with the other board, everything is pristine and clean, and now I can continue with a visual inspection. Although I'd rather wait for every bit of the IPA to have evaporated. You can clean water, but if you clean water, you need to soak it with IPA to take any moisture off the board, because water, you know, dirty water especially, can be quite conductive. I haven't yet taken that out. I have tested it, it's fine, but I could do it. Yeah, you can see that they've been having a bit of a hard life, can't they? Oh, there we go. Nice looking board now. And there's an indication of a bit more. We can even make out what the chip is. And we move across, looking for any more ICs on here. They're usually just logic gates. Possibly a resistor. Oh, I don't know what that is. I'll have to look that up and see what type of chip that is. Maybe a PAL encoder maybe, I don't know. I don't think so. Yeah, just dabbing it gently. Wiping it off my trousers, that'd be nice. There's big IC on there, look you. IC integrated circuit, for those that know. For those that know, well, you don't. There we go. Okay, let's test the switch. My switch test in operation means I'm going to put that into continuity mode, and that's the lead bringing the power in, and there's only 2 connections coming out, which is the live and the neutral. And we're going to start with the big one. We're going to start with the live itself, which I've connected there. So are we on, or are we off? We seem to be off at the moment. Let's switch it on, and you can hear that bleep. Oh, that's fine. Try the neutral. Right, interesting enough, if it's going to be something as simple as the switch, I will be highly disappointed. So we've got no neutral. Which is unusual to say the least. Okay, we've got no neutral, we've got no feedback, so we've got live, but we've got no neutral, because we haven't changed the wires, that's why. There we go, we got neutral. Sometimes we all make simple mistakes. So it breaks the live and the neutral, and just to make sure that the earth is going to where it should be going to, and the earth will be here. Yeah, that's the switch is okay. That's what we can conclude from that. We've been looking pristine and clean. I've dried it the best I can. There's only a little residual IPA. I've gave it a visual inspection all over, and I've cleaned up many of the leads now, and that top part. I'm going to reassemble it and see how we get on with a power up. So it's just reverse of what we got to do. Starting with that, needs to go back on here because that's the support for this, so that's the main switch. I'm going to turn that around just so as you can see, and that the switch will probably go in there like so. Now I've got to remember where I put all the screws. I haven't lost any. The first screw that I took out was over there, followed by that one. And the last screw, which hinges down, is over here. So I should really start with the reverse. And of course these need to be not just pinch tight but really tight, because this is what actually earths everything. Because the earth's connected to there, then this is connected to like the steel rail that goes across the back and connects everything basically to ground. Should there be any dead shorts, you want it to blow the fuse, which I'll put a 5 amp fast blow in. If I've lined this up right, which I haven't, just see if that's in line. Oh yeah, I've got to push it down a little bit. There we go. And that should be in line now. Not quite, just a little bit of play maybe. You know, I might start with the other one. The other one looks a bit simpler to get. So yeah, I think I'll start with the other one. You don't need to see me fiddling with that for the next 5 minutes. There we go. Like magic, the screws appeared. Now this I have not recapped. Right, I've not recapped it because I doubt if the reason why it's not working is anything to do with the cap. So, but what I will do is I will now put it back into place. And how handy was that it had pin headers to click down on. And once they're in the pin headers, they should align up here with these tabs. And as always, nothing is ever straightforward. It's been stubborn. Ah, right, okay, you can see there's like 2 little keys that go down there and there that I sort of wasn't in line with. That's in there, in it goes. There we go, we're getting there, everything's starting to click back together. We can connect the power up, which is internal down here. Look, can it go either way, or is there just one specific way? We don't need to go either way. Let's have a look, see which one's alive. And by looking under the board, yeah, we can see there's markings on the board telling you what is what. So we know pin 2 is missing, and if you can see that, there's like a key there, and it's these 2 there. So I'm going to connect them up now. Oh, you probably didn't see, did you? Oh, okay, let's give a close up. Right, if you look on the board there, yeah, the neutral is the top pin. I believe it's neutral, and that should be alive. But neutral will be even. We can just bleep it out and make sure, because annoyingly, you shouldn't be able to push this in either way, right? The neutral is going to go that way according to that, which means it's the bottom pin, because this doesn't go in either way. You know, it can go, yeah, or does it? Or does it? Neutral should be the top pin. Oh, actually, it's referring itself to the top, so yeah, it seems to be fitting in one way. I don't know, you didn't quite catch that in camera. Let me get that round. There's the connection there, as you can see, and it does say neutral at the top, and that's looking like the case. I'm trying to keep my hands out of focus there. Right, let's see if we can pull this out. Right, can we put it in the wrong way round? Well, we can, but it'd be wrong that way because you'd be further forwards than it should be. So I presume that that is the right way round. Our presumption is the mother of all mistakes. So best to bleep it out. So I have spotted something, and it's to do with this resistor, which when it gets too hot, the solder on here is designed to melt, and that's under like friction and will spring open and break the circuit. And coming over here, and it could have been something I'd done, you can see that that's precisely what happened. So I'm going to have to reconnect that temporarily and see if it gets hot and desolders and breaks the circuit again. It may have just simply got too hot in there and that may have come apart. That's wishful thinking, but we've got to start by thinking we can get away with that. So let's reconnect that. Okay, I've soldered that back on and it's under tension, so should it get hot it will break that connection. It is important what type of solder you use. You need a solder which will, shall we say, melt at a slightly lower temperature in order for that to flick open. I happen to have the right temperature, and I did do a bit of research online, so now hopefully with that being safe we can start putting the rest of this back together, get it in the chassis. I've gave the tube a small clean. I've not gone over the top on it, of course. I don't want to at this present moment in time go full force, get busy one time cleaning the whole thing up. I just want to get it to a situation when I can now test it and see what goes on when we pair it up, and hopefully it's not going to be too bad of an issue. But you know, we don't know. It could be the tube that's gone, it could be the flyback that's gone, it could be a number of things, or it could be none of the above. It could be simply that has gotten too hot and that's come off, and that's the best case scenario. And with my track record, the best case scenario tends not to happen. Obviously, while it's open, you know, it would be a good time to recap it. I've just found a second fuse that I've missed, and it's been staring me in the face down here. I will need to test that, and the fuse I'm looking at is there. Now, it looks to be okay. You know, it looks to be like there's a wire going from A to B. We can test that right now by getting my probes into multimeter and continuity mode. Yeah, that's fine. And there's what I missed earlier, but it's fine, it's making connection, shouldn't be a problem. The tubes, I haven't really gave it a massive clean up. I've just cleaned it enough, and you can see there's like a white stripe on there, and they've all been marked, so that was a good handy hint. But it looks like it's moved over slightly because it's disappeared off the glass. But these are quite stiff, apart from that first one. I'm not going to touch that just yet. I didn't want to, you know, gently brush around here because I don't want to knock any of these fine wires off. It looks like there's no problems with the insulation, just gently dabbing. I don't want to, you know, I don't want to end up breaking any of them or knocking any of the insulation off it and causing a short, because then those windings will be no good, although the tube probably will be, as long as I haven't done too much damage there. So let's zoom out and bring over the newly cleaned and potential problem fixed circuit board. I say potential because you never know. You never know when you're going to get lucky, and you usually know when you're not. Okay, now supporting that, before we put anything else on, there's a lot of fine wires here. I want to move that out the way because that's going to get to the front. We've got to connect the earth, and once that's far enough on the edge, we can twist it round, because it's the last thing I disconnected. It's the first thing I've got to reconnect, and once again, this is not going to be easy. I need my trusty long nose pliers, and as always, can't find them when I want them. I've got these ones. Right, let's see if I can twist that up. Then knocking the circuit board on the floor. Let's push reconnect this air lead. Don't know that my arm's going to be in the way. If I've got that there, and just push that on. There we go. I know that's connected now. And if I twist it up out of the way, it's not going to be any problem. So, here goes. Let's get this in the tray. Okay, we're up there like so. We're in the tray. That seems to be over the top. But yeah, these are keyed, so you can only put it in one way. But I don't want that getting in the way of everything else. I could have done with that earth lead going underneath. I might have to unplug that and re-plug it in. Yeah, I did have to re-plug it and plug it back in because the leads were slightly in the way of each other. Now, I need to manipulate this gently in and around. I want to keep all these wires away from each other a little bit and not trap anything. I can see some of these pins, and this is worrying because I don't know if I've done that or what. They just look a bit like I've knocked them down a touch, so I'm just going to give them a gentle. This is not recommended, by the way. I need something a bit smaller than that. I don't think they're going to go in that well. Maybe I'll just need to give it a little lever up. There we go. There we go. Are they all okay? The rest seem okay. Okay, now then. So we got that. That's going around there. And this should gently align with that. I mean, you've got all these wires. They're always in the way, and you know it's never easy. Never easy. And that is permanently connected to the board, so that's the way it was. There we go. Oh, that's gone on nice, actually. That's gone on nice. Right. Before we reconnect that, let's connect this one in. I want to put that underground, overground womble in 3. Wombles of Wimbledon. Now, because that looks like there's a blank pin there, and there's a blank pin there, we can't get that wrong. That's good. That's in. Maybe I can manipulate that away from the flyback transformer. I mean, it's shielded anyways with that outer casing, so it should be fine. And that's got a plastic shield on it too. That's okay. That's connected to there. Now there's another connection somewhere. Yeah, of course, the degaussing one, which has got a neutral and a live. Or has it? Because I didn't think it mattered which way round this went, but it must do. And that won't reach, so I've got to actually push the board in a little bit further in order for me to get that connected. What I'm talking about. I think it's just a loop circuit, isn't it? Yeah, 1 and 2. Just make sure. Yeah, because it is just a loop circuit, really. So I don't think it matters too much which way around that goes. I could be wrong. But I do remember it going this way, so I'm going to put it back in the way I saw it go. Was out. That's it. Right. Let's push that right in. Oh, that's as far in as we can go. Okay. Now, this is the part I always connect last, and I've cleaned it up nicely, and you can see the way that they, just like a couple of hooks, I sort of open it up, click that in, and then we're done, and I'll push it down nicely. I can't remember if it was facing downwards or something like that, because I don't want loads of wire that way, so let's think of the best way to do it. I think it was something like that, to be honest. Or was it? Right, so let's twist it round. Oops! I don't want to go flying underneath anything, so sure, the high tension. It's It's been a bit awkward. It's like it's too long. Did it go underneath and around? I don't think it would have done that myself personally. Right, okay. Let's get my trusty tweezers on the effector. They've got to be strong tweezers. Just want to get the first one clipped in. There we go. Second one clipped in. Okay, that's in. There we go. Right, so yeah, I'm not happy about that, I'll be honest with you. It seems a bit, you know, how's your father? But yeah, well, it's probably going to be okay. I'm probably overthinking it. Keep it away from the tube, maybe. That's, yeah, that's okay. I'm happy with that there now. I think we're ready to put a plug on this and give it a power up, which is always a worrying time. I'm due now to give it a power up, but because that component there was desoldered slightly, before I do that, obviously I've got to have the switch out of reach, so that I can get to it fairly quickly, but off the camera and away from everything to see if this is going to power up. 3, 2, 1, and off. Okay, so there's one thing I forgot to do. Now, 3, 2, 1, 1 again. Well, that sounds promising. Well, that is promising. That is very promising. Oh, and we've got it powered up. Let's take it up. Look. There we go. Let's put a signal in this and see how it reads. Okay, so we've got what appears to be a signal. We just turn everything down. Now there's a switch issue here. Oh, we've got a picture. It's very green, but we've got a picture. It's in monochrome. So let's have a look. Let's see if we can get it into focus a little bit. We have got a picture. That's a good sign. Yeah. Oh, very sensitive. So yeah, we seem to have lost a bit of colour. Can we get colour on this? Or have I got it in the wrong setting? Right, let's yeah, we got colour. Boom! Oh, nearly boom. I think we just got a slightly dirty switch. Oh, is it the switch? Could be just the connections, but it's something round here. Ah, Christ. Yep, that needs a lot of deoxit. Yeah, yeah. I think we needed to clean the switch. But we've got a picture, which means the CRT is good, and we've had colour briefly. We're getting there. I just need to do a bit more deoxit, and hopefully we can clean up that switch. I'll show you the switch I'm talking about. It's that switch there. There's the switch here, and it's really not happy. So if I can get any type of deoxit in there, I don't want to be careful because there is some voltage in here now, you know. Maybe even some into there as well. Oops, don't want to be doing that, do we? Just give me a little help with the contacts. Oh, God. My hands are all wet. This is not a good situation now. Okay. We really need a mirror in order to do that, and what I've done basically is I've now sprayed that switch, and really we should just work it in a touch. maybe tilted to one side. Okay, people. The big reveal is this Trinitron TV, which is slightly out of focus. Well, we can work on that. He's working! And that's from Dead. And it was basically, it's just one simple thing. I mean, you know, it's, well, I've still got to put that cap on there. Now I've got to be careful now because there are voltages around. That there had just got hot enough to desolder itself. It was simple as that. And it's amazing, just with the amount of dirt and gunk that was in this television to get it up. Sorry, television, monitor. To get it up and running, well, that's quite the reveal. I'm going to just tart it up a bit now, put it back together. Consider that a win-win situation. Maybe I should play with a few of these just to get it into focus. I think we could do with just moving it over a touch. I really like gloves when I'm moving with things like that. Yeah, I don't want to touch it too much because it's not major out. It isn't perfect, but it's not major out. We're good to go. That is up and running. Front view to finish off with. There we go. I'm going to have to compare it with the other TV, but we've got another working Trinitron monitor, and that only cost me £10 and probably a little bit of repair time. Thanks for watching, everybody. Retro Robbins. More repair videos. If you want to see any more repair videos like this, drop me a message in the messaging and I'll happily do them. I don't like doing repair videos, but you know, I will do them for you if you're keen on seeing this sort of thing and getting things up and running. Take care for now. Bye.
Retro computing has a place in our hearts. From Sinclair to Commodore, where do we start? 8-bit computing in the modern age, where vintage computers take center stage. It's the Retro Robbins Show. Retro Robbins Show. Plug in a joystick and let the good vibes grow. The Retro Robbins Show. Go live, subscribe, stay in the know. We've got reviews and gaming vibes. We do upgrades and repairs, all of it live. So come to the channel and just drop in. Take off your hat, let the show begin. Let's go, let's go. Let's go, let's go. It's the Retro Robbins Show. Retro Robbins Show. Plug into your computer, let the good vibes grow. The Retro Robbins Show. Go live, subscribe, stay in the know. Oh yeah, take it away. Oh yeah, take it away.